Now, having an inclusion-exclusion formula in hand, let's see if we can tweak this a little bit more, see if we can extract some more identities. This is a dangerous Venn segment, a bonus lecture. Sample it if time and discretion allow. Okay. We have an identity for the probability of the union of two events. What can we say about the probability of the union of three events? Of course, in terms of conjunctions. Now we'll have many things to play with. The raw probabilities of A, B, and C, the intersection probabilities A intersection B, A intersection C, B intersection C, and also the probability of the intersection of all three of them. In settings like this, if at all possible, one should draw a picture in the sage advice of George Poulier and say, let's draw a picture. A generic collection of three events A, B, and C have got complicated interrelationships as sort of shown in that figure. Now, we want to deal with the union of the three events. Now, that's complicated, and the idea, of course, is to try to decompose it in terms of disjoint elements, and in such a way that we can utilize the inclusion-exclusion formula we've already discovered. All right, so let's start with a decomposition of A union B union C in terms of first A union B together with C. Now we've got two events, A union B and C, and we can apply the inclusion-exclusion formula to those two events. In this case now, A union B takes the place of A, and C takes the place of B, and we've got an inclusion-exclusion formula, a sum of two raw probabilities minus an intersection probability. Let's look at the elements on the right-hand turn. For the probability of A union B, we've already discovered an inclusion-exclusion formula, so we just write it down. This next term is just the probability of C, there's nothing to discover there. And then we have a probability of A union B intersected with C. Leverage the distributive property of intersections over unions and rewrite that event as the event A intersection C union B intersection C. And now, in the right brackets, we've got two events, A intersection C and B intersection C. And we have their union. Well, it's all right now again for another application of the basic inclusion-exclusion formula, with now A intersection C taking the place of A and B intersection C taking the place of B. We write the formula down. Okay, at the very end we've got the intersection of two objects, but we realize that if you intersect C with itself, you just get C, and therefore we now have all the pieces needed to write down a formula for the probability of the union of three objects. We write it down in terms of a sum of three objects, a difference of three objects, and a sum of a single object. And if we look at this carefully, pictorially, you'll realize that what we're really doing is again following through on the principle of inclusion and exclusion. We first add the elements A, B, and C, and we found we've got too much. The stuff in the middle of the intersection is overcounted, right? And each element is overcounted exactly once. So you subtract the three elements in the middle. But the moment you do that, then the intersection of all three of them is accounted for three times, once in A, once in B, once in C, and subtracted three times, once in A intersection B, once in A intersection C, and once in B intersection C. And so we have to add it back in to make the calculation fair and just. It's a little bit like thinking about, let's say, the way a pendulum might swing, right? You let it go, and it overshoots, and so it comes back, and it undershoots. It goes up, it overshoots, it undershoots, it overshoots, it undershoots, and it finally settles down. And this is exactly the process we are following, an overshoot-undershoot phenomenon. Each time we overshoot, we take away something from it, and we find we've undershot. So we go back and add some more elements, and eventually we get exactly where we need to get to. The listener can well see how one can expand on such a formulation and talk about the probability of a union of, say, n events. And I'll let you have at it.